Okay, everybody. It's past, so I think we're good to go. My name's David Richardson. I'm going to be chairing the webinar today. Before we start, there's a few housekeeping things just to go over in the next couple of slides. The webinar's been recorded, so and it'll be available to people afterwards. Everybody who's taking part in it, from your point of view, are just in listen mode. So if there is a problem, you can raise your hand there, using that to get something from the host if you need to do. During the webinar as well, we're not going to be taking questions during it and asking them to the people that are presenting, but if you could type them in the Q&A box, which is shown there, that would be really good. And if you're also watching it and you like the questions that are being asked, you can also give it a thumbs up. And that'll give us a clue as to which of the questions, if we're starting to run out of time, which are the questions to cover. You can share resources in the chat. That's if you've got any links to anything and what have you. And hopefully there'll be a poll at the end of it as well. What I'd like to do, first of all, we're looking to finish around about 12:30 if we can do it, so it's going to be a bit tight, really. But what I'd like to do is just cover things about CIRIA, if you don't know about it. CIRIA recently celebrated the 60th anniversary. It's not a not-for-profit member-based organisation, and I think its core strength has always been to improve performance through collaboration in the built environment and construction. And how they do this is by developing guidance. So there's things like SUDS manual, the ROC manual, which I think a lot of people have seen, stuff on asbestos and biodiversity. As you know, we've got a particularly strong legacy in asset management and geotechnical guides. And I think recently they've covered things like UAVs and GIS and what have you. And CIRIA organise around about 50 events a year, mostly online, but they do conferences as well and debates on these particular topics. So yeah, it's quite a wide-ranging organisation, covers a wide range of topics. These are the members. So there's about 80 members at present, but it's growing all the time. And yes, you may well see your organisation within there. This is today's programme. As I say, we need to keep it quite tight, really. And I'll introduce each of the speakers as they come through. So really, as an introduction from myself, I guess, what is wireline logging? The first measurements were made down the hole in 1927 by Conrad Schlumberger, and he was measuring electrical resistivity. Over the years, there's been more and more techniques that have been developed. Existing techniques were improved, and a lot of the early use was in mining and oil and gas. But it's been used more extensively in ground engineering now. So yeah, the technique for all of these sort of measurements down boreholes is wireline logging. It's defined as the measurement of downhole formation attributes using special tools lowered down into the borehole. Personally, I've spent a lot of years looking at the geology coal mining projects and then laterally into large civil engineering projects. And I'm a big fan of wireline, as I'm sure some of you'll know. And I felt that there could be a potential for a guide to make more people aware of the huge range of techniques, that and the outcomes that are available. So without further ado, as they say, I think we'll get into the webinar. So our first speaker today is Dr. Charlotte Usher. She's a principal geophysicist at RSK Geophysics, and she's going to give a brief overview of a recently published CIRIA guide on geophysics, not down the hole, not wireline. But I think what this is going to do, hopefully, will give you a taste for how these guides can be used and what we're going to be trying to use. So I'll hand it over to Charlotte now.
David. Oh, sorry. So basically, as a bit of background on those of us who end up writing this guidance. So I work for RSK Geosciences as part of the geophysics team. We have experience in a wide variety of critical infrastructure projects, R&D projects, collaborating with industry and academic partners. We've been involved in the writing of a number of existing guidances, such as PAS 128 and British Standard 5930. So we've got a lot of background in writing these things, which really helped with writing the CIRIA guidance. What I'm going to go over in my small part of this session is just kind of summarising what the guidance is, why it's important, and then sort of like covering the main findings that we've got from that. So CIRIA C812, it was published back in December 2023. A key thing to note is it is a guidance, it is not a standard. It is a tool that people can use to advise on how to use geophysics in ground investigations. It doesn't replace site-specific advice from a geophysical specialist. It is a client's guide, so it is targeted at clients, at contractors, at regulators, the people that are looking to commission a geophysics survey. It's not aimed at those who are using geophysics on a day-to-day basis. It's not used for practitioners. This is a key feature of our guidance. We have these call-out boxes which highlight key elements which are linked to different stages of the investigation, within case studies and within the main discussion. They're points that we want to draw your attention to. The aim being that you don't get caught out. You can learn from previous experiences in similar situations. The main aims being that it wants to provide you with a better understanding of where and when geophysics is good and effective to use. It shows you what that good practice looks like, and it gives you confidence and empowers you to ask questions and not just to accept everything that you're being told. Now I'm going to go over the main findings. The first thing we wanted people to take away from this document is the extensive information that geophysics has the potential to provide, with the key emphasis again and again that this is on a site-by-site basis. We reiterated throughout this document how the geophysical surveys work on one site might not be the same as they work on another site. The example here on the right shows a buried utilities survey when this was undertaken with just an electromagnetic location tool, such as a CAT scanner. There were several plastic pipes that were missed, which were shown during trial pitting, including 2 water pipes and a gas pipe. Had GPR been used, ground penetrating radar, as is advised within the PAS 128 guidance, then these utilities would likely have been identified. The next thing to highlight is that, as with any survey, making assumptions about what's going on below the ground might not always be correct. In this case, a geophysical survey was completed on a former military camp in Greece. It was understood that there were 3 tanks present on the site. So a survey was done over the area they believed the tanks to be present. And assumptions were made about what sort of anomaly you would expect to find a tank directly buried in the ground, which is how they understood the tanks to be present. And only one of the anomalies that were highlighted on the site actually met those assumptions. However, during further investigation of other anomalies on the site, it was identified that the reason that those anomalies were not as expected is because the tanks were not all directly buried in the ground. Some were in brick-lined containers and some were under surface features which were masking their signal. The next thing to note is that geophysics does have its limitations. We rely on the measurement of differences between a target and its surroundings, or between 2 different geologies, as you would with wireline logging. In the case of geophysics, this difference is in physical properties such as the conductivity or the shear strength of 2 materials. We may not know what this physical property is, like the change that we're looking to measure before we go to site. So in these cases, multiple techniques are generally advisable, which is one of the benefits of wireline logging, in fact. In this particular case, you can hopefully see the contrast between the green colours in the north, which is a higher conductivity limestone, and the blues in the south, which represent a lower conductivity sandstone, which is mapped in plan view. In cross-section, this is identified as a normal fault within electrical resistivity data, with the blue low resistivity materials on the right, which are the limestones in the north, and the red high resistivity materials in the south, which is on the left. However, these 2 materials were not detectable by seismic techniques, which suggested they had very similar compressibilities and shear strengths. There's a few examples within the document that highlight that geophysics isn't perfect. It doesn't work every time. These surveys do not replace an intrusive investigation. They are best when used alongside. And the reoccurring theme of a document is to use geophysics as part of a phased investigation or to target intrusives. The example shown here, geophysical surveys were able to identify the lateral extent of a landfill with an accuracy of 1 meter. However, they were not able to obtain a measurement of the depth of the conductive waste. Combining the lateral extent measured by geophysics with the borehole investigation, which determined the depth of the waste, meant the volume of waste was able to be calculated to within 0.3% of the total volume that was recovered. Another thing that we've highlighted within the document, which is relevant here, is that there's many topics that were touched upon within this guidance that should have or do have their own guidances. They are a document within themselves. They were mentioned within CIRIA C812, and they are still relevant, and they are still an important part of using geophysics in ground investigations. However, as David mentioned, it kind of highlighted that there's certain elements like borehole geophysics, of which the example shown on the right here is actually of a wireline survey, need to have their own document, which is what's motivated the creation of this new document. So I'm going to hand over now for more discussions on that topic. Thank you.
Thanks very much, Charlotte. That was really a really good introduction to what the CIRIA guides are really all about. And I think also what you've done is shown that, you know, there is potentially a need for one for wireline logging. Doesn't just cover geophysics, which I think, you know, we need to stress, but it does cover other techniques as well. And again, as Charlotte said, a lot of these techniques should be used in conjunction with other things, and that's hopefully what we'll be looking at now with with Balázs. So just a couple of things. Please, if you've got any questions, write them in the question box. And also, if you like the questions, to do a thumbs up. So that'll help us to see which questions we should concentrate on. So the second presentation is from Balázs Rigler. He's UK Wireline Services Manager for Frugro. And he's going to be focusing now on, I guess, what we are looking to talk about, which is wireline, but in particular, wireline logging in hydrogeological situations, and there are obvious links then to potential environmental issues. So I'll hand over to Balázs now.
Yeah, thank you, David, for the introduction. Thank you very much. Good morning, everyone. So today I will present about wireline logging applications for hydrogeology and environmental reasons. So wireline geophysical logging for hydrogeology and environmental applications can be divided into 4 main application groups. So the first one is for groundwater and hydraulic parameterization, groundwater flow evaluation. And the second one is groundwater quality logging and water sampling inclusive as part of wireline logging. The third one is aquifer evaluation, design of water wells, and then technical check of completed wells, casing inspections, casing integrity checks, etc. So wireline geophysics is very much linked with other geosciences or applied geosciences, such as, for instance, hydrogeology, engineering, hydrogeology, geotechnics as well. So all those engineering applications are pretty much linked together. So this is an example of how wireline logging could derive stratigraphy if the right combination of methods would be chosen, selected on that purpose. So simply with wireline logging, those are the stratigraphy lithological indicators, and also sensitive to aquifer quality. We can reveal aquifer, different aquifers versus depth in boreholes, and also stratigraphy. The next slide, I just want to talk a little bit about nuclear magnetic resonance, which is, we call it a old new method, which is actually, this method is actually older than 50 years old. So this method measures the water content of the formation. The same measurement principle is applied to MRI scanning in the health sector. And more recently, it's also used for surface ground geophysics. And I think it was Schlumberger, the company who service provider in oil and gas, started to use the NMR for oil and gas reservoir characterization long ago. And then more recently, from the 90s, roughly, the method is also used for groundwater investigations. And then really very recently also for geotechnical investigations, ground investigations. So this is an absolutely safe method. It doesn't require radioactive source. It is also often called downhole magnetic resonance or borehole magnetic resonance simply. It is a nuclear method, but it is a magnetic nuclear method. What it does, basically, it measures the water content and distinguishes between bound and mobile water fractions, and also between capillary and clay bond fractions. And in that way, if you measure that water content relatively accurately, then if the formation is fully saturated with water and fluid, then we basically measure the porosity without using radioactive source, versus neutron porosity, for example, which requires a strong radioactive source in usual. So the method also provides estimation of pore size distribution, and if we know the water content, the porosity, and NMR data acquired by the method, then hydraulic permeability, conductivity, and transmissivity can be estimated as well in a very high vertical resolution. Also, formation density can be estimated using the direct relationship between porosity and density from petrophysics. It is very well documented in literature. It has been very well documented long ago for decades. If the formation is not saturated fully, then the method only measures the moisture content of the formation, which would still be a valuable parameter for different geotechnical applications. For example, tailings dams or quick lay or landfalls, etc. So it's just an example from the UK, one of the first ground investigation, geotechnical ground investigation carried out with NMR logging. We replaced in 2018. We replaced the neutron porosity with the method in chalk. We investigated the chalk in Ipswich. So on the left side, we can see that colorful log. With the darker blue represents the capillary bond water fraction. The light blue is the free water fraction. And then on the right side, we can see the permeability estimated from the measurement. We can see the direct relationship between the permeability, conductivity, and the capillary bond water section. So this is and not very much of a clay in the chalk formation there. So the method is very, very effective in chalk, as well as unconsolidated sediments, sands, silty, lithologies, soils, also limestone, sandstone environment, as it was investigated in oil and gas exploration plenty of times before. So the next example is from the Lower Thames Crossing project, which was carried out a ground investigation project for the Lower Thames Crossing scheme in 2019. We applied nuclear magnetic resonance among other violent geophysical methods listed on the left side, and many more, which is not visible in the picture. So just want to emphasize the importance how accurately the NMR permeability correlates with the pucker testing, hydraulic pucker testing results, which can be seen with yellow bars represented on the right-hand side log. It's really a good match within order of magnitude from chalk lithology, again from London. There are plenty of other examples from different lithologies. For example, HS2 site, ISP2 related land investigation sites as well, and also from environmental applications, logging, monitoring wells, and also offshore wind applications. It's an example. Estimation of density is now broadly used for offshore wind clients in their investigations. This is very well published and available online, the report as well. So a bit more about the hydrogeological water applications. So with borehole cameras, casing inspections can be carried out. These are just example images about casings, clogged casings, scale on the slots, the slotted casings. In the next slide, we can see some more examples. On the left side, we can see before cleaning the borehole, how it was looking with the camera. And then on the right side, when the borehole was actually cleaned, cleaning procedure was completed, we can see the difference. So borehole cameras are very useful for investigating status of wells, casings, and boreholes as well. Evaluation of formation hydraulics can be carried out with flow meters, Wireline flow meters. There are different type of flow meters available. It can measure the flows, the inflow, outflow at certain intervals. The next image is an example, a composite log example of a flow, a hydraulics log interpretation. So the fractures, it is an example from metamorphic hydrolithology and artesian borehole. So the fractures can be revealed by logging a caliper for borehole geometry, and or acoustic or optical televiewer, and the flow zones can be interpreted or found and the flow rate can be determined as well in certain intervals. The next slide is for casing inspection again, and annual space inspection. So it's often required to seal off different aquifer layers to prevent contamination, cross-contamination of different strata layers. And that can be done with grouting, but it's very important to check the grouting quality, and can be done with a full waveform sonic log, which is also called cement bond log. In casings, this is an example of cement bond log on this slide. The next example is a water well inspection using optical televiewer. Rusting can be revealed, integrity of casing, and also cracks. Casing thickness of steel casing can be logged with acoustic televiewer. So the acoustic televiewer is not only beneficial for open hole applications for discontinuity mapping, but it's also beneficial for water integrity checks, water well inspection, and casing integrity checks. This is another example of casing thickness on this image. So it's just a short overview about hydrogeological applications, but many more examples could be provided. So Wireline geophysical geology is efficient services method, so it's time and cost effective, provides multi-parameter data simultaneously. Multi-parameter data can be acquired, high resolution, in situ, and unique information can be provided at low risk. Thank you very much for your attention.
Thank you, Balázs. That was really good. I think what it does is not just focus on the hydrogeological side of things, but I think what you've shown is that there are lots of different techniques that you can use, both within ground investigation, but also within, when you've actually put something in place and you're looking at production from wells. So I think it's Wireline has lots of different applications, and there are lots of different techniques. So thank you for that.
Thank you.
Next, we're going to hear from Roshi Hussain, who's the Senior Geoenvironmental Engineer at Curtins, and from Dr. Ross Pettigrew, who's a Senior Geoscientist at Task Frontera Geoscience. And they're going to be presenting, again, on wireline logging, but for geological and geotechnical applications. And their particular focus is going to be on image logs. So I'll pass you on to them now.
Okay, thank you, David. So, yes, as mentioned, we're going to focus on image logs. So what are image logs? Image logs are orientated petrophysical maps of the borehole wall, and they provide readings of the formation and the fluid. And these are displayed as colored pixels along the depth of the hole, and in Y and X by the angle of the true north. And this is just a schematic diagram of the sort of the wireline tool. So in geotechnical applications, televiews are typically used, either acoustic or optical. And then this is just a sort of base schematic of the tool that would be lowered down into your cored hole, into your open hole. So looking at the rock. Image logs have been used for decades in the oil and gas industry, and I've just put a sort of a basic sort of workflow of what the application has been traditionally in the oil and gas flow industry. Here, I've highlighted in yellow sort of the main applications that would be useful for sort of geotech, geoenvironmental applications. And I guess the main application really would be for sort of in situ feature detection and orientation. So orientation of fractures or faults or bedding dips, and also being able to orientate core to features in the borehole. So some examples of image logs here. So this is an acoustic image, an orientated petrophysical map. Acoustic tools, they generate travel time and amplitude images. However, they work only in fluid-filled boreholes, but they can also image through thick flush and can work through PVC. So this is a nice image taken from European Geophysical. And on the right-hand side here, we see an image through PVC. And then here is just an example of the tools from Robertson. The other most common type of image tool is the optical televiewer. This is an orientated, unwrapped image of the borehole wall. It provides images in high resolution and in real color, and this works in air-filled or clear fluid boreholes. However, the image quality can be impacted in heavy flush or where there's a lot of sediment or in suspension in the hole. And again, here's some nice images and the tool. So why should you run borehole images? The main advantage is they can be ran over long intervals and they can provide a continuous record of the borehole. This is especially important where you have core missing or recovery is poor, and it provides in situ feature orientation data of your bedding dip, your faults and your fractures. Some disadvantages, acoustic borehole televiewers, they aren't photos, so they can be limited by the tool physics itself, and they can be affected by the hole conditions, mud types, and acquisition practices. And also, especially with acoustic borehole images, they can be limited by the interpreter. So if you're unfamiliar with these images or what you're looking at, you may not get the most out of your data. So we're going to look at a case study here. This is a legacy coal mining site, the Glasgow Geothermal Observatory, drilled by the BGS, where 12 boreholes were drilled. One was logged with acoustic televiewer, and 3 were with the optical. And this data is all freely available on the BGS website. So just the green here is the optical holes and the depths, and the red is the acoustic. So a quick explanation of the workflow. So images from the tools, they're loaded, processed, and QC'd. False color images are generated. So the acoustic televiewer, this is necessary. Optical, you get a photo almost, but you don't necessarily need to generate a false color. However, this can enhance features and provide better contrast. And then next we generate dips. So when you have an inclined plane going through a borehole, this will be unwrapped as a sign in a 2D plane. So we will manually pick this sign and computes the feature orientation on a summary plot, which are displayed as tadpoles. If you're unfamiliar with this, here's our sort of summary plot on the right here, and the tadpole tracks. So the circle here indicates the dip, and the tail of the tadpole is pointing in the orientation. So for example, this example at the top here is dipping at 20 degrees to the northeast. And now Roshi will take us through some of the results.
So, as mentioned, borehole image logs taken from the Glasgow Observatory showed multiple lithologies and structural geological features. It's important to note that when we interpret borehole image logs, we often combine them with other logs such as gamma ray or neutron density logs, just to solidify our interpretations. So gamma ray, just to give you an idea, is it will measure the natural radioactivity of thorium, uranium, and potassium in your formation. So in this example, we identified sandstones. So sandstones have a typical signature of a low gamma ray and low neutron density value. If you look at the image on the left, that's your acoustic log, and the image on your right is your optical image log. If you look at the right, the red lines are potential cross-cutting features that we've interpreted as cross-bedding, and often you can also see some fractures along. It's important to mention that the cross-bedding and the fractures are often your pathway of least resistance, and this is where you're likely to have your fluid flow or your contamination pathways, which is quite important for us in geoenvironmental or geotechnical ground investigations. We also identified mudstones. So again, you've got your acoustic log on your left and you've got your optical on your right. So mudstones, unlike sandstones, will have a high gamma ray and high neutron density separation. So this is how we kind of like pick out that you've possibly got a mudstone. Your mudstones tend to have low angle dip of bedding. So the green lines, as you can see, are practically horizontal. We also identified coal. Now, coal has a low gamma ray value and anomalously low, like very low, neutron density values. If your false color images don't necessarily pick out the coal very well, going by your anomalously low neutron density values is a good indication you've got coal in your borehole. And we also identified some geological faults. So geological faults are cross-cutting features. So in this example, that pink sine curve that you can see on the right in your borehole image is your geological fault. and the green lines are truncating across your fault. If you look at the borehole image on your left, you can see if you base it on the tadpole dip that Ross had mentioned, you can see that the mudstone beds are actually steepening upwards towards the fault. This is usually indicative of fault drag. And so if your fault isn't clearly picked out by the borehole image, this is an idea of like, you may have a fault on your site. Next slide. Okay, and then there's also fractures, as previously mentioned. So fractures is something that we really struggle to correctly log when we're core logging. It's really difficult to orientate it, and image logs are quite a good and accurate way to get your dip and your azimuth. You can also identify if your fractures are open or closed, which is something that's very important, especially for geothermal ground investigations. Or it's also good to indicate for example, if you're doing grouting treatment on a coal site, you can give your client an idea of actually if you've got loads of fractures, lots of open fractures, your site is likely to take up quite a bit of ground. And fractures can often cluster along a hole, like in certain lithologies or around a certain point, as you can see. We also identified a few geohazards. So this is very important for engineering. So in this example, we identified evidence of workings. So if you look at the image on your left, at the bottom, you can visibly see that there is a void that's present. And you can see that because you can clearly see a hole that's present. On your right, in the middle, you can see we've identified another void. Here, however, in the distance, you could possibly see that actually it may have been backfilled with made ground. And then we've got more examples of workings. So in these images, we can see that there's actually potential pillars that you can see in the distance where we've identified a void. But it's important to note that the image on the right, if you see the bedding dips above the void, it's generally relatively low angle bedding. That is what I typically mentioned previously. However, if you look to the left, your bedding of your mudstones are actually steeply dipping. And you can also see some increased fracturing. And this is indicative that you actually have ground movement or fault block rotation. And this is likely to be associated with your workings that have happened historically on your site, and it could possibly lead to subsidence. So I'm going to pass it over to Ross now.
Thank you. So yeah, just finally, as for any of the geotechs in the audience, we can also determine some principal stresses from borehole images. So the type of in situ stress that we can work out is your SH max and SH min. And we'll get these from features called breakout or drilling-induced tensile fractures. So breakouts, here's an example here, and drilling-induced tensile fractures are sort of long lineaments that are often seen in the borehole wall. And borehole breakouts are perpendicular to your SH max, whereas drilling-induced tensile fractures would be parallel to your SH max. So if you see any of these examples in your image, you have a sort of indication of where your principal stress directions may be.
So to summarize, I think using borehole image logs is very important to ground investigation, especially to support our scope of works. It provides confidence in your data set as well as reducing error, and you're reducing the amount of assumptions you're having to make, especially for coal mining legacy sites where you're actually trying to investigate whether there are workings below your site, and that may affect your future proposed developments. It increases your detailed understanding of your site ground model, both in terms of geo-environmental and geotechnical. And it's not just for coal legacy sites that it's only applicable to. You can use it for chalk or evaporitic sites where you can identify dissolution features or where you might have flint bands. So there's a wide variety of applications. So you should consider it. So thank you for listening.
Thank you, Roshi and Ross. I think very interesting, primarily because I think it shows that images are not just for looking at things. They're fantastic for correlation in a lot of respects, but there are a lot of other uses for them, and there's a lot of other information that you can get out of it. So that's yeah, fantastic. Finally, I'd like to welcome Dr. Loretta von der Taan, who's a research manager at CIRIA, and she's going to be sharing the proposal on wireline logging that we've sort of formulated. So I'll pass you on to her now.
Thank you. I'm not sure. Thank you, whoever did that in the background. Thank you. Yeah, just a very few words from me. Thanks to all the panelists. I think this is a really interesting session already. And it's really a companion guide to the guide that was presented by Charlotte, C812, and targeted similarly at clients, contractors, consultants who might commission wireline logging surveys. So it's not, the idea is not to be directed at specialists, people who are already specialists in geophysics or wireline logging, but rather a short document that allows to get an overview about what is possible, which techniques might be useful for a specific case. That gives you the confidence to ask questions, to quote Charlotte. But I think the presentations already showed that it needs quite a deep understanding for correct interpretation, and I think that is not what this guidance will provide. It's rather a list. It will be signposting to literature and other resources, and it should also be a compendium of case studies, so showing examples of applications, so that the reader has an idea of what can be done, and to facilitate learning by example. We also hope that it might be a resource for teaching, as CIRIA guidance sometimes are. So the proposal that many of you might have seen when you signed up to this webinar, otherwise please get in touch and I'll send it to you, is to cover the whole range of applications of wireline logging and to show that wireline logging techniques can deliver high-resolution data about in-situ properties and in a time-efficient manner. So it's really to get more out of the same borehole when you do boreholes already. And it shall, teach the reader or be a source for understanding when it is pertinent to use which wireline logging techniques on a specific site or to gain a specific information. And yeah, just promote the benefits of wireline logging techniques. The timeline, if we manage to get enough funding together, we'd like to scope the guidance in autumn and write it next year. So please get involved. Please let me know if you're interested in getting involved. We are fundraising, so we are looking for people or companies who might be able to help us sponsor this guidance. We will at some point also look for authors. So if you were interested in writing also, please get in touch. And if you have any questions at all, feel free to email me. And that's it. I'm handing back to David.
Thanks, Loretta. That nicely summarises where we think we want to go, and also asking for money. We've now got a Q&A session, so if all of our speakers can turn on their microphones and webcams, then we'll see what questions have come in. We have a question that's come in from an anonymous attendee, and basically they're asking, will the proposed guide address the issues arising from the use of these techniques in non-vertical boreholes. So obviously, where you have a particular structure that you may be looking for, it may be more pertinent to plan your site investigation with non-vertical. I'm going to throw that to Balázs, because I think if that's okay, because I'm sure you've had experience with non-vertical.
Yes, yes. I mean, logging non-vertical boreholes is very common in wireline logging, really. I mean, obviously, oil and gas, they often drill vertical and then turn to horizontal to reach the reservoir to find oil and gas. But also geotechnical purpose, drilling horizontal boreholes for tunnel construction development applications might be useful as well. And many of the available wireline logging methods can also capable logging horizontal boreholes or highly inclined boreholes. There are strong limitations, different limitations, but it's possible to do so. But I understand. Thank you for the question. Really, it's a good question. That this feature of wireline logging is not really utilized at the moment for geotechnical applications, and I think the benefit is there for using these methods for highly inclined borehole logging, and this is something I think we should really look into. Thank you.
Great, thanks a lot.
I hope it answers partially, at least, your question. Thank you.
And I think it shows as well that there are lots of different ways that you can use this, and not necessarily just in vertical, obviously. So I hope that answers
just
Anonymous's question.
May I just add one more thing? So obviously, many of the wireline logging methods require a medium in the borehole to be able to log the necessary information, to obtain the information. So media, I mean, fluid in the borehole, so water or borehole fluid must be present in the borehole for successful signal transfer, especially for acoustic, sonic methods, seismic methods. And it is really more challenging to maintain water level in a highly inclined boreholes and horizontal boreholes. It can be done, but it's a challenge.
And I think also that's the advantage of having different people that we have today, but wider as well, who've got experience with not just the interpretation of it, but also the practicalities of doing it. And I think that also, as with the guidance that Charlotte mentioned right at the beginning of the session, it's using people to give practical experience as well as just the interpretive side of things as well, which again Loretta said is not really the purpose of the guidance, but so it's the practicalities of it. Yeah, we had another question as well from Mateen from Technology Experts Riyadh, and he was just basically asking a question about tadpoles, Ross. And he just basically wanted to know, is the tadpole orientation with reference to magnetic north or some other reference?
Yeah, so the orientation of your hole can be essentially whatever the project is. In vertical, yes, it would be sort of true north or magnetic north. Building from what we said about deviated. In deviated holes, we would usually orientate it to borehole high side or low side. But it's a good question, because you need to make sure that everyone's aware of your reference point in your hole. So it's something that needs to be sort of agreed of at the project start, really, that we're orientating everything to true north or magnetic north. So, but yes, it's variable, but it can actually have implications if you have the wrong reference point set, that your angles and your inclinations could be wrong.
Great, thank you. We have another question from another anonymous attendee. Can we use ATV or OTV for casing inspection. I think that was sort of covered by you, Balázs, wasn't it?
Yes.
Yeah.
Yes, it's definitely possible. Yeah, I showed some examples in one of those last slides in my presentation, represented applications. So yes, acoustic borehole imager can even measure the thickness of steel casing, the quality of casing, corrosion level, rusting, and optical televiewer is also useful. Obviously, optical televiewer is not a camera, CCTV borehole camera, but it provides a very high resolution oriented image, not in steel, but in plastic casing, for example. But in steel casing can be useful to inspect casing damage, integrity of casings. Yes.
Good. Thank you. I hope that answered that
Yeah.
question. Another couple have come in, and I think we'll just stick with these ones and then sort of wrap things up. I've got a question about the over-enthusiastic picking of discontinuities from the image logs. The question said, this is challenging and can present a problem in practical geoengineering versus theoretical. And then it says, will the future guidance provide a steer or advise on this? I think I'd probably go back to either Roshi or Ross on that one, the over-enthusiastic picking. I mean, this is down to interpretation now, which again, I think the guide won't tell you how to interpret, but that's got to be left to the interpreter. But I think what they're saying is, will it provide a steer or advise on it?
I would say it's always good to have image experts look at this to avoid that. But also, if you can combine this with core photography, even just you get a sort of you can see a good guide of, is this artifact? So yeah, especially with acoustic images, you can have a lot of sort of artifacts or borehole wall damaged, which if you're not familiar with that, you may pick that as a sort of a fracture or a fault or a discontinuity. If you have core images or from the core, if you cored, that can provide a good sort of reference point either way. So you can see, okay, is this a drilling-induced fracture in your core? We don't see it in the image, or is this an artifact in the image that we don't see on the core? So I suggest both techniques should be worked in combination, really. Maybe that's something that the guidelines can state, that use all available data for best informed decisions.
And I think it also goes back to making sure that you have someone competent to interpret the data, so you wouldn't just have your engineer on site making these interpretations. So you'd get someone in like Ross to do the interpretation, but also they would probably take a judgment on what exactly he's picking out and what would be useful to the project, because every project would have a different purpose and outcome.
Following up that quickly, sorry, you can also what my company does is we often assign a quality level to your picks. So you have essentially one is, yes, we know this feature is there, or sort of 0.25, we're unsure of that. You could almost do a range of sort of your feature quality and confidence. So if you're unsure, you can assign a confidence level to that pick, so people aren't saying, okay, we know this feature is there, it's a maybe, which may be limited by the tool physics itself.
Great.
And maybe if I can just quickly chip in terms of the scope of the guidance, the way CIRIA works is that we will have a project steering group, and that project steering group is very instrumental in helping and steering the authors as to what shall be in the guide and where is kind of more density in information and where is less, and where maybe the focus of the guidance is more, as has been said, the collaborative nature and the kind of making sure that you have the right data and you get the right techniques for the right questions to answer your questions, and to have to cross-reference across different kinds of information you have down the borehole. Thank you.
And I think we've just got, I just want to ask this last question. I think there's another couple that have come in, but we can answer. Is it right we can answer those later, Loretta? Yeah. But just one final one, and this is for Charlotte, and it sounds like a yes or no one, but have you noticed any changes in the use of geophysics in ground investigation since the actual publication of the CIRIA guide?
Yeah, I would say there's certainly been a lot of interest in when I've been presenting it, and people have been saying that the guidance has helped them to give more information, to ask more questions. But I think, to be honest, it's also helped us as geophysicists to kind of like pushing us to do better effectively, to make sure that we're, like Ross said, stating quality of our outputs, and better trying to communicate better with other geoscientists, because it's one of the barriers I think that we've had up until now, is that we don't appreciate how our jargon, that the people don't understand what we're saying, and trying to be a bit clearer about what we're doing is ultimately going to help more people want to use geophysics, because they'll understand it better.
Yeah, brilliant. Thank you. I think it's useful to know that they actually work, and the guidance is valuable, and yeah, hopefully this one will be used similarly. Right, I think it's probably about time to wrap things up. So I've just got some closing remarks to make. So first of all, I'd like to thank everybody who's joined us today for the webinar. I hope you found it interesting. Wireline logging is such a large subject. I think we could only touch on a few of the many different methods and data that you can get from running these sondes down the boreholes. So, as I say, we're not suggesting this guide is going to be an academic course on interpretation of it, but more of like a go-to publication for when specific problems might present themselves in planning site investigations, and obviously suggesting where wireline may be used, and also how it can be used in conjunction with other techniques and with the other guides. I'd like to thank Charlotte, Balash, Roshi, Ross, Loretta. Thank you for your contributions today. And I'd also like to thank the support team at CIRIA who've yeah, just make these events happen. Yeah, very difficult to get up and running, but they seem to make it happen very easily. So thank you. We will be circulating a link to the speaker presentations at some point, and any of the questions that came in that we didn't manage to cover, we will try and respond to those. And if you have any additional questions, just call any of the CIRIA team. We're also keen to hear about what you thought about the webinar as well. So yeah, there's the feedback. And then there's also a question about whether or not you would like the receive CPD for this webinar as well. So you'll need to complete that poll to get the CPD. If you missed the launch of the covering it. If you missed the launch of the webinar for the CIRIA publication on geophysics in ground investigation, then there's a link to it there. And then I've been told also offers on the 10th. There's an offer. There you go. For actually purchasing that guidance as well. So type in Wireline 20 before the end of the 10th of June, 20% off. So yes, I think that about covers the webinar, and we are spot on time. So hope you enjoyed it, and catch you later.